Hello, let's continue our Sudoku adventure with Skipping Stones by Matt Tressel. So, along with normal Sudoku rules, we do have parity lines that are also, I forget the name of them, maybe counting lines, something like that. But so the lines double up in rules, so do pay attention to both rules. All right, so let me go over them. We have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. These lines in the grid are also parity lines. So parity is just the fancy math term for even or odd. And it's a convenient term in puzzles because you can generically talk about even oddness without saying even or odd every time. So adjacent digits along a parity line, one has to be even, one has to be odd, right? We alternate between even and odd as we move along the line. So if this was a 2, that's even, this one would have to be odd, maybe a 5. This would have to be even again, maybe a 6, right? And we'd have to keep going like that. Now, in addition to that, if a digit appears on a line, that tells you exactly how many cells on that line contain that digit. So if I put a 2 on the line, then exactly 2 cells on this entire line, like only 2 of them, exactly 2, and only 2, are a 2. Hopefully that makes sense. Now, if the digit doesn't appear on the line, it doesn't appear on the line. That's fine. It's only if it appears on the line, then it's restricted to being exactly that many. So it's 0 or as many as that digit is. And this is a separate line. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Well, I can tell you this line is guaranteed, right? Because you can't put a digit bigger than 3 on it because it's only 3 length. So like if I try to put a 4 on it, that means I need 4 cells on it to be a 4. But 3 also doesn't work because then all 3 would be 3 and we'd repeat 3 in this column. So only 1s and 2s appear on here, but we know that we have to alternate parity. So I'd either need 2 1s in a single 2 or 2 2s in a single 1. And we know which one of those breaks the rules. So we just immediately get those digits. That does put a 2 up here. So now the next thing I'm going to do is I'm going to color this. I'm just going to alternate green and purple, and that's going to represent it switching between even and odd. But we don't know which one's even and which one's odd yet. So we're going to have to figure that out. So I think we're going to have to do some logic here in terms of how many unique digits must be on here, and then because of those digits that must be on here, which ones, like the big ones, like 6. Like, do we have a 6 on here? And if so, that has to go in the green cells because if you think about it, every box has 1 6 in it, right? So if I do have a 6 on this line, then I would need to put a 6 here because it's the only cell in the box that's on the line. So actually pretty similar to the Asylums puzzle that we did the other day with counting, what are they called? With look and say cages. Anyway, so can we prove that we must have a 6 on the line though? So can we omit the 6 from the line, I guess would be the other question. It looks like it should be possible to place a 6 in every row column box such that it's not on the line at all. So I'm also going to start coloring these even and odd. I like to use blue for even and orange for odd. I started because orange starts with O, but and blue just contrasts really well with orange. But now I'm just extremely used to it. And if I do anything else, I get confused. So I've been doing it for years. Let's see. So we've shown that if there's a 6 on the line, it must appear that would make green even, and this would be a 6. So that's a great effect, but I don't know if I can prove we must have a 6 on the line. We have at least 4 distinct digits on the line because of this box and because of this column. So maybe I should count how many there are total. Well, we know, okay, evens and odds. That's really interesting. So, okay, well, hold on. Let me just count the cells. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 16 cells on the line. So whatever unique digits we put on the line, add to 16. So if you think about it, like it's just like counting circles if you've done those. I think we did a whole theme week on counting circles, if I recall. So if a digit appears on the line, it appears that many times exactly. And so if you think about it, the number of cells used by a digit is equal to that digit. And we know there are 16 cells. Therefore, we need unique digits that sum to 16 so that they occupy exactly 16 cells. So for example, if we have a 6 on the line, then now that uses up 6 cells, there's 10 cells remaining. So now we could do a 5 on the lines, and then now that uses up 5 of the cells, and now there's 5 remaining, right? So you can see that we've just subtracted 6 from 16, and now we've subtracted 5 from 10. So we need at least 4 unique digits that sum to 16. Now I can tell you 5 unique digits at minimum are 15. So we could have 4 or 5 unique digits. We cannot have all 6 digits because all 6 digits sum to 21. That would use up too many cells. We also know that do we know that? I was going to say, well, we have at least 2 evens and 2 odds. We can say that. So if we had 4 unique digits and we wanted to sum to 16 with 2 evens and 2 odds, that does work. That is an even number. If we include a 5th digit, it has to also be even. So one thing we can say is that there are exactly 2 odd digits on this line, and 1 odd digit is omitted. That's interesting. And so the reason we can say that is because we know from look at this box, it has 2 evens and 2 odds, right? So that's even already. These unique digits sum to an even number, and we're trying to get to 16. So if I add an odd number to that, a 5th digit that's odd, that's going to change that sum to odd, and there's no way it's going to be 16. So if I add a 5th digit, it has to be even. So I have exactly 2 odds, which are the ones in this box and the ones in this column, and then 2 or 3 evens. Now, let's think about what 2 odds we would use. Can we use 3 and 5? That sums to 8. That leaves 8 to be the even digits. So 2 even digits that add to 8 would have to be 2, 6. 3 even digits adding to 8 doesn't happen because 2, 4, 6 adds to 12. So if I used 3, 5, let's just scratch this out. If I used 3, 5 as my odd, then I would have to use 2, 6 as my even. If I use 1, 5 as my odd, I don't know if this is what I'm supposed to do, but this is interesting. Anyway, if I use 1, 5 as my odd, then this is just scratch space here. Let's just do it down. It doesn't matter. That adds to 6. I need 10 more. So again, 3 even digits add to 12. So we're not going to do that. So we need 2 even digits add to 10. That would be 4, 6. The other option is I'm going to be using 1, 3. 1, 3 adds to 4. So then to get to 12, I could do 2, 4, 6. That's one option. And that's the only way I'm adding to 12 with even digits. So these are our options. I either have 1, 3 with 2, 4, 6, 1, 5 with 4, 6, or 3, 5 with 2, 6. So the conclusion here is I have to use the 6. Omitting the 6, I cannot have only 2 odds. So yeah, I need to use the 6. And so then that proves that 6 is on the line, which proves it's here and that green is even. That is really cool. All right. So now we know evens and odds. That means this is 3, 5 because they can't have a 1. And that tells us exactly that this is going to be, let's see, 3, 5 is 8. This is going to be 2, 6. So all of our evens are 2, 6. Now we only get a singular, we only get 2 2s on it. So the rest of these are 6. Ooh, no. Oh, sorry, this 2 is not on the line. Okay, yeah, so we get this 2, this 6, this 6. That actually works out. Perfect. 2 2s and 6 6s on the line. The rest are 3, 5, and we have to remember that we need a 5 in every box. So this has to be 5, because this box isn't contributing a 5 to the line, so every other box needs a 5 on the line. So that's 5, that's 3, that's 5. Cool, that is very good progress. So we know that basically the 1 and the 4 are not on the line. That's 1, that's 4. I'll just continue coloring. I think that's fun. So let's see how much coloring we can get done here. That's a 1. This is 3, 5. Oh, it can't be 3. So that's 5. And then down here, we need 2, 3, 4. Let's just mark that out. Okay. Any other obvious colorings? Well, this is 1, 2. This is 3, 4. So that's our 4. That's our 3. Even and odd. So this has to be odd, and it's a 1. This has to be odd also. And it's 3 or 5. And then this is even, and it's a 4. This is even 4. These are, oh, we do need a 2, so that 2 goes there in the box. And then, so then this is our odd 1. So that's not a 2, so that places our 2 here, that's even. So this has to be odd, and we know it's a 1. This has to be even, and we know it's a 4. That gives us 3 and 4 here. 3 is odd, 4 is even. Our coloring is done. And now how are we... Oh, so for count, we probably have to do counting here. So that's a really interesting way to resolve these, actually, is counting. So we have a singular 3 and 2 5s. So we need 2 more 3s and 3 more 5s. So if this was a 3, this would be a 3, and this would be a 3. That would be too many 3s. So this has to be a 5. So we get 5, 3, 5, 3, 5, 3, and we're done. That was really cool. I like how the way I approached it. Thanks, Matt. That was a really fun way to think about it, and proving that the line needed a 6 on it. Really, really cool. I really enjoyed that. I haven't done a puzzle like that in a while. It felt very unique to me. So really cool idea, really good execution. Enjoyed that a lot. Hope you did too. If you did, then why not leave a like, subscribe, and a kind comment below.